Question B4 from the 2012 Advanced Higher Applied Maths in the Maths section, 7 marks this time. The first 3 marks, express this in partial fractions, where x obviously can't have a couple of values and it tells you them, 0 and -1. Well, first thing would be factorise that denominator. X comes out leaving you with x plus 1. So splitting it into 2 parts would be something over x, because I've got 2 linear factors for the denominator, and b over x plus 1. That's not an equation, that's an identity. So we can find a and b by, let's multiply it all by x plus 1. So that means that would turn to 1, but I'm going to write it on the other side. So that means I've got a would get multiplied by the x plus 1, having cancelled the x. B would get multiplied by x, having cancelled the x plus 1, and that should come to 1. And then you've got 2 techniques. You can solve this, which is still an identity. So it means it's true for any value of x, just by choosing appropriate values of x. So you'd probably say, oh, let x equal 0. And then obviously a is 1. Well, I've just said it, so we'll just say that. Let x equal 0. That means you've got a, just jump straight in with it, a is 1. And pick another value. If x is -1, that means that negative b is equal to 1, which means that b is equal to -1. Or, comparing this, again as identity, side for side, these 2 expressions must be identical. So you could also say, what if we compare it term by term? What about the constant term? Well, the constant term on this side is 1. The constant term on this side is a, so straight away a is 1. Of course, you'd use this more often in the case where you've got repeated factors in the denominator, where using a substitution doesn't eliminate them all. And let's compare the x terms. Well, the x terms should come to 0. And the x terms are made up of a plus b should equal 0. Well, if a is 1, that means that b is -1. But the same might work both ways. Which means, in any case, express that in partial fractions. Well, that would be 1 over x minus 1 over x plus 1. Where there was 1 mark for separating into 2 fractions, and there was 1 mark for each of the values of a and b. And so the second part then, what have we got? A region is enclosed by the curve y equals this. That's just the same expression, only with the square root. The x-axis and the lines x equals 1 and 3. Calculate the volume of the solid of revolution formed by rotating it through 360 about the x-axis. 4 marks. Well, don't need a picture of it, I'll just put one down anyway. So ignoring that square root, just to get a rough shape, that's a reciprocal one, isn't it? It should look like this. Notice it goes from 1, luckily, because it's 0. That's going off as an asymptote. So between 1 and 3. So it's this little shape here that's getting rotated around the x-axis. Just like one of those paper decorations that would go round to form a shape, and it would go round to form this lampshade shape. There's a wee tongue twister, lampshade shape. Now, how would you get the volume of that? Well, you consider it's split into little discs. Each of these little discs would have a volume of pi r squared h. And then you'd add them all up. So that volume is going to be the sum of pi, and then the radius will be the y coordinate, and h would be the thickness of the disc, which would be dx. That's what you'll be using. So, what have we got here? The volume will be, and going from 1 to 3, from 1 to 3, pi is a constant, take it out, y squared, I think I'll just jump straight in with x squared plus x, dx. And that in fact is the first mark. Well, in fact, the first mark was for leaving the square root in and have the whole thing squared. But I made that statement there, that should cover it. Well, obviously, it's related to part A, so I'm going to pop in the partial fractions. 1 over x minus 1 over x plus 1 dx. So that's a mark, which will be pi times log, because they're just linear underneath, ln, and I'll just put x. I'm not going to put the little safety brackets around it, because x in this example can never be negative, it's between 1 and 3, minus ln of x plus 1. Again, I'm just putting ordinary round brackets, because in this case, that expression will never be negative, between 1 and 3. If you want, you can put in the wee safety things, the wee modulus, the wee absolute values on either side. It shouldn't make any difference here because we've got specific values. In the general case, you'd have to say that, yes. Now it's just a case of evaluating that, so putting the numbers in. I think before I put the numbers in, maybe I'll just tidy that one more little bit, because when you're subtracting them, you'll be dividing the arguments, so it's that I'm going to work out. So it's pi times ln, putting the 3 in, it'll be 3 over 4, putting the 1 in, it'll be 1 over 2. Tidy up one last little bit, that'll be ln of divide by a half is the same as multiply by 2. I've used another line in now. So that v, because I'm not getting any more room, would be pi ln 3 upon 2 for its exact value. Maybe I should just finish that off with units cubed for good measure. Now, if you want, you could find the value of that, which is approximately 1.273, etc. Maybe we'll put an 8 in as well. But generally, you would stick with an exact value unless there was some specific reason for having a number to use somewhere else. So that was the second mark. Third mark for integrating. Fourth mark for obtaining the answer.